Hello, my dear young and energetic physiognomy. A very warm welcome to Diksha Vedantu YouTube channel. I'm your master teacher Neha ma'am. In today's session, we are going to discuss about units and measurement. So we have already started the foundation series, right? So just a second, let me check that live has started or not. Just let me wait for a few minutes. Hmm, Let us just wait. It's going to start, I think. So yeah, I was discussing about that. We have started the foundation course, which will help you guys to start your 11th preparation, right? So we are just bridging the gap between your 11th and 10th. And also, so this chapter is from your 11th standard physics. That is the first chapter which you are going to cater. Before that, we used to have that physical world chapter, but in this syllabus, they have been removed it. Okay, so that also I have already took the session. If you are interested to watch it, if you want to know physics, you can just go through the sessions. Okay, and also I have completed basic math session that is required for your physics, as some of you may have choose just PCB. So without mathematics, it's difficult to enter and get a good marks in physics, right? So I have already done a video on basic maths in just two videos. You can just go and refer that if you want to make your basic strongs before solving any physics question. So I have planned the sessions with the very basics. Okay, so first I have to the introduction, that is what is your 11th and 12th syllabus is like. Okay, those students who haven't watched the video, you can just go and go through the videos. If you want the video link, I can put it in this video description. So the process is very clear. Okay, I'm not taking any random topics and teaching it. It is in a flow. Okay, first we will understand the syllabus. That video is already done. Okay, then I have taught what is physical world, why we should study physics. Okay, after that basic maths is done, and today in today's session we are going to study about units and measurement. So before studying about any other chapters like motion, temperature, or etc., so we must know the basic things like as units, right? You already know that when we write about mass, we write it in kg. If we write distance, we write meters, right? This meter, distance, this kg are nothing but they are called as SI units. So how they originated and what's the proper method to use them, these kind of basics we are going to cover in today's session. Is that clear? So before entering to the session, I'm just clearing you what you're going to gain from this session. Okay, so as I said, with a very basic flow, very planned way, these sessions are going to be run. Okay, it's not I'm just taking anything and teaching, it's in the flow. Okay, if you're in the flow, if you're studying with me one after the other, so I'll make sure that you will not fumble when you go to your 11th standard. Okay, in that way I have planned it. Okay, great. So shall we start then? Yes, tell me quickly, shall we start the session? Just a second, let me just refresh these things. Yeah. So then let's start, right? So with the basics. Okay, great. So yeah, units and measurements, it is very important because we speak about distance, we speak about velocity, we speak about temperature, we speak about current. So these all quantities are measurable quantities, right? We say that this much of volts, this much of current, this much of distance. So we measure those quantities in particular numbers, we'll say. But basically, before the introduction of SI units, the world was like somebody used some other units, other people, other kind of units. So there was a problem between the transaction of the goods within the people. If I consider the weight, the mass in the kgs, someone would have considered it in pounds. Okay, so if I go to some other country, they will measure their units in the unit of pounds, the mass. So there will be difficult in the transaction of goods, accurate measurements, and the change exchange of currency. So these kind of issues, problems were running in the world at that time. These SI units were introduced. Okay, so this is how the SI units came into the picture. Sorry. Okay, so let's giving you a basic introduction. So why units and measurements are important in physics? As I said, we measure so many wide range of quantities that we want some accurate measurement tool for that. Okay, you have seen. Yes, hi Quizmaster. Yes, yes, I remember you. How can we forget our students, right? So yeah, I remember you. Okay, hello. So I was speaking about the units and measurements. You have seen that, right? The vendors, the people who will be selling vegetables, they'll be having this weighing tool. They'll keep the stones, they'll measure the things, right? So to make it all proper, these units were introduced. And for physics particularly, physics is a science based on accurate measurements. So there is accurate measurement present in the physics. Okay, if I tell what is the distance between sun and earth, some accurate distance should be there. It may be as long as that distance, or it may be simple as from your home to some your schools or your college, right? So there is a number, there is an accurate distance, there is an accurate measurement. So what is matter? Very basic question. We all know that already. Matter is nothing but anything that has mass and occupies space. Right. Now, this matter we measure in varied quantities. We measure its length, we measure its breadth, we measure its weight, and all the quantities. Right. So, this is about we are going to measure the matter. Clear? Yeah. To measure these quantities, we use standard units, standard measurements. They are nothing but the SI units. And I'm not just going with the textbook definition. So some extra things I'll be saying here so that you don't lag anywhere. Okay. So our physical quantity is basically divided into two groups. Okay. The complete physical quantity, nothing but the quantities that exist in the world of physics. Hi, hello. Yes, hi, Vijendra. Hi, hi, hi. Hello. Okay, just a second. Okay, this physical quantity can be divided into two types. One is the all the quantities that are present in physics. One is yes, yes. One is called as physical quantity. So the entire quantities that are present in universe can be divided into two types. One is physical quantity and the other one is non-physical quantity. Okay, physical quantity and non-physical. Computer science exam of what? So study the things that are provided. Okay, so I don't have that much idea about that, right? So uh, you can get to know it with by your seniors or in the schools, right? So physical quantity and non-physical quantity. Yeah, is it present in the class? Do you guys already studied this? Tell me, is this already you know? So see here. So as I said, one is physical quantity, other one is non-physical quantities. And further, physical quantities can be divided into fundamental physical quantities and derived physical quantities. So let me write it down. Entrance exam, computer science entrance exam. Which one is that? It is from which class? This is for your this chapter is present in your 11th standard physics. And it is the basic. And I'll show you that 2 to 3 questions in JEE appear from this chapter. Very easy, very basic. First chapter, there will be some questions which you don't know answer also. With the help of dimension analysis, with the help of SI units, we can find the answer. There exist these kind of questions also. Okay, so I'm explaining it. Okay, so as I said, there are two types of physical quantities: fundamental physical quantity. Okay, one is fundamental and the other one is derived. Clear? So two types of physical quantities, that is fundamental physical quantity and derived physical quantity. Now here comes our SI unit or whatever we are going to study. Okay, so fundamental is nothing but basically that exist in the nature. Okay, so all the physical quantities that we see are not the fundamental one. So nothing but multiple different quantities are made by using these fundamental quantities. And what are these fundamental quantities? The things that we study as length, time, right? So these are called as fundamental quantities. Example is length, okay, time, the temperature, the heat, what we study, right? And yeah, current, mass, right? So SI units, basically what we study, they are the fundamental quantities, and other all the quantities except this fundamental quantities are called as derived quantities. They are not nothing but derived from this fundamental quantities. For example, force. So force is not a fundamental quantity. Why, ma'am? Because force is taken as F is equals to ma. So m is nothing but a fundamental quantity. Using a fundamental quantity and other quantity, we derive this quantity. Right? Getting the point what I'm telling? These fundamental things, they exist in the nature in the basic format. I cannot construct length using some other quantities, but I can make force by using mass and acceleration. Understanding what I'm telling? It may be pressure, okay, force per unit area. We'll be using multiple quantities to create one quantity. They are called as the derived quantities. Okay, so you can consider pressure, volume, okay, length into base into height, or yeah, volume, pressure. So these are all example for the derived quantities. Is that clear? Yes. Or any other you can consider. But the basic are the things what we study as SI unit. So we find the unit, we'll decide a standard unit for fundamental quantities and easily. If I say that fundamentally the SI unit of mass is kg, and we know that SI unit of acceleration is meter per second, because meter per second square, right? Because distance is divided two times, nothing but velocity by time, right? Getting the point what I'm telling? So see here, I know the basic SI unit, so I can derive this SI unit very easily. In the place of mass, it is kg. In the place of acceleration, it is meter per second square. So what is the SI unit of force? It is kg meter per second, second square. You may say that, ma'am, it is Newton. Yeah, it is Newton because it's discovered by Newton. In this format also, if you write kg meter per second square, it's not wrong. It is also the SI unit of force. Clear with this? So what is pressure? Pressure is nothing but force per unit area. Just use the SI unit of force here, and SI unit of area. Area is nothing but meter square. Right? So the square meter cancels, and this is the SI unit of pressure. It's Pascal, but the standard one is this. Am I clear with this quantities? Tell me quickly in the comment. In the chat, those who are watching, let me know that is it clear to everyone? Is it clear? Right? Okay, so this is about the basic introduction which you should know before you're studying the physics, right? In physical quantities, there are basically two types of quantities. One is fundamental, that exist in a raw form in the nature, is called as fundamental quantities. Derived quantities are just made by the mixture. So you can just remember it as fundamental quantities are nothing but the food or nothing but the vegetable fruits which we grow from the nature. By using that vegetables, we prepare lots of dishes, right? We prepare curry or we prepare sabzi. These are all nothing but the derived quantities. Clear? Getting the difference between fundamental and derived quantities. Okay? I hope that is clear here. Done? So shall we move forward? If it is clear, let's move forward. Oh, so now moving forward to the SI units. So I said no, in the olden days before standard units were discovered, people used to measure in their own ways. So there used to exist these different kinds of systems like CGS system, FPS system, MKS system. Then we had this standard unit that is nothing but SI unit. Okay, in CGS system, people used to measure in centimeter, gram, and second. Okay, their standard unit was centimeter for the length, gram for the mass, and time for the time they used to measure seconds. So yeah, hi, hello, Pari, hi, hi. Okay, so that was about CGS. Then FPS is foods, pond, and second, right? Still now also we can see in some other countries they will be measuring the length in foods and weight mass in ponds. Okay, so these kind of in some place some unit they were using, some other place different unit. So there was problem, as I said in the beginning of the session, the exchange of goods, the exchange of money was not properly going on. Not only that, for the discovery, if the scientists want to use some chemicals or some solid weights and all, there used to be very different measures for the different countries, right? So finally, to solve this issue, they all gathered together and formed a standard unit which will be used across everywhere. It's not like in India, it's for everywhere. Standard unit was formed. Is it clear? So understood what is so SI is nothing but system of international unit. It's not just to India, it is international unit. Internationalized. Yes, I means internationalized. Is it clear? Okay. Shall we move forward now? Okay. Right. So we are clear with this. Then comes the standard SI units and which you have to remember. You have to remember in the sense you should know what is its symbol and what is its SI unit. Okay, so we know that length is measured in terms of meters, right? So meter, you should write full form meter or else just the symbol m. And be careful, any change in this is not accepted. You cannot write m into t for meters, it is not the accepted symbol. Okay, if you write this kind of wrong symbols, the teacher may deduct the marks because the standard thing that is decided is small m. That's all. It is the SI unit of meter, and not you cannot write capital M also. It is also wrong. Only the small m is the SI unit of length. So remember, SI unit of length is meters, not kilometer, not centimeter, or not anything. It's just meter, and small m is the SI unit. Done. Then comes mass. Mass is nothing but measuring the weight present, right? So mass denoted with small m, and its SI unit is kilogram. So again, be focused here. It's not just gram, it is kilogram and written as kg. Okay, is it clear? So it is written in the format of kg. Then you have time. So you can see that time was not changed in any kind of SI unit. It was kept as seconds, and now also we'll be using it as second. So you have seen that while I was solving the numericals in your ninth standard, okay? So we'll be converting the time into seconds. If they give the time in hours, if they give the time in minutes, we are going to convert it into the seconds and then only we'll calculate. So you should know what is the standard unit. In the question, if it is given, a vehicle is traveling with the speed of 100 meter per second for 6 minutes, what is the distance traveled by it? So you should not use the 6 as it is. What you should do, you should convert it into seconds. You can just multiply 1 minute is equal to 60 seconds. So 6 minutes is equals to 6 into 60 second. Okay, is it clear? Okay, just a second. Is it clear? Right. Okay, just a second. Fine. Okay. Yeah. So next is for time it is second, for length it is meter, for mass it is kg. Then we have electric current, right? For electric current we know the symbol is I and current SI unit is ampere. We studied this in the 10th standard electricity chapter, right? Then temperature, that is nothing but thermodynamic temperature or temperature, that's okay. It is denoted with capital T. And what is the SI unit? It's not degree Celsius. Kelvin is the standard SI unit of temperature. Is it clear? So remember, it's not degree Kelvin, it's not degree Celsius. The SI unit of temperature is Kelvin. Okay, amount of substance, right? So what is amount of substance? It is denoted by N, amount of substance present in some molecule or some you use this more in chemistry. Okay, so that is called mole concept. You have this chapter also. Okay, then comes the luminous intensity. Nothing but we will be speaking about how intense the light is, right? So the SI unit for that is candela and it is denoted with CD. And for mole you'll write MOL, not E. That is the unit, that is the symbol. Okay, so if you want the PPT I can share it. Okay, if you cannot see some of the symbols, that's okay. So I'm saying you the SI unit of current is ampere, capital A, Kelvin, capital K, mole, MOL in small letters, and candela is CD. Is that clear? Right, tell me, is it clear? Yes, hi, Tanushri, hello. How is the ninth preparation going on? Yeah, okay. Shall we move forward then? Is it clear to everyone? And this is important. Okay, I'm not just simply saying it, it's important. You will be using this with the flow of time, with the time. Okay, is it clear? Shall we move forward? Good. It's going good. Great. Good then. Okay. Shall we proceed now? Okay, let's proceed. So, not only this standard units, that is 7, I guess. 1, 2, 3, 4, 5, 6, 7. Yes. Not only this 7 standard units, but also we have 2 supplementary units. The 8th and ninth one. Okay, now let's discuss about the supplementary units that were introduced later for a circular arc kind of structures. Okay, the supplementary units are plane angle and solid angle. So plane angle, if you're considering, if you're measuring any angle, right, which is plane, okay, it's considered in the radian, or else you can consider it in 2D dimension, 2 dimension. Okay, so there is a structure like this. I'm considering this. Okay, this is called as a plane angle. So it is measured in terms of radian, not theta or not in degrees. It is measured in radians. And in the yesterday session, I think, okay, in your basic mathematics session, I have given you the conversion between 1 radian, how to convert it into degrees, right, and how to convert 1 degree into radians. So we have already discussed about this in our basic math session. Okay, basic math session, we have already discussed about this. So that is what we are speaking here about. And this solid angle is nothing but it's for a three-dimensional object. So if there is any object like this in the 3D, if it exists, so here we measure the angles. Okay, here we measure the angles in the form of steradian, right? SR. Clear with this? So these are nothing but the measure of angles. Measure of angle in 2D and measure of angle in 3D. Clear? Any questions, any doubts? If you have, you can just put it. Just a second. You can hear the voice properly, right? Any questions, any doubts? Yeah, I hope the sound is clear, right? Okay. Next. Shall we move forward? Yeah, shall we move? Voice is proper, right? Okay. Let's move to the next one. So supplementary units, they are also important. So just remember what are the SI units, what are the standard things that are present. Okay. Time, length, mass, electric current, thermodynamic temperature, amount of substance, luminous intensity, and plane angle and solid angle. So these are the standard things we have to remember. Okay. Shall we move forward? Okay. Moving forward. So now this table is also extremely important. You'll be asking, ma'am, how to convert milli, what is kilo, what is micro, what is nano, and etc. 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 So this table is very important, right? So when I entered to the first year, first PU, okay, we just sat and study by hearted this table in a one go, right? We were so excited to study physics in the first year, so I just sat and I just mug up all the things, and still they sit in my head. So I remember them. Okay, so you have to be perfect in that way, because in the questions you'll not only get meter, you'll not only get Kelvin or anything direct. They may give you in the form of tera, giga, mega, kilo, hecto, deci, centi, milli, micro, nano, pico, femto. So you have to remember them and their SI units also. So there is, yeah, these are things are important. So starting with tera is nothing but 10 power 12. Okay, very big unit. Then comes giga means 10 power 9. Mega is capital M. Most of the students get confused with mega, milli and micro. Okay, there is a difference between mega, milli and micro. It appears to be as same as M, but it's not. Mega means capital M. This capital M represents that it's a big number. Big number is nothing but 10 power 6. Small m represents small number, that is 10 power minus 3. Okay, so capital M, mega means 10 power 6. Small m, milli means 10 power minus 6. Then comes the micro, which is more smaller than that, that is minus 6. Mega 10 power 6, micro 10 power minus 6. Between that lies milli, which is 10 power minus 3. Right? It's not that difficult also to remember this table. You can easily remember this. Kilo, we already use it. Kilograms, 1 kilogram. Yeah. How much it is if it it is converted into grams. Kilo means 10 power 3. So 1000 grams. 1 kg is equals to 1000 gram, right? So these kind of conversion you should know. Okay. Then comes the hecto. Hecto means 10 power 2. Deci means 10 power minus 1. And centi. Sorry. Sorry. I just got cold. I'm from morning. Okay. That's fine. So deci means 10 power minus 1, centi means 10 power minus 2, milli means 10 power minus 3, and micro is 10 power minus 6, nano is 10 power minus 9. You'll also study about the nano physics, okay? The particles which we study in very micro level in the power of 10 power minus 9. It's called as nanoscale. In the nano scale, if you are studying about physics, so that is called as nanophysics. So that branch of physics also exists, okay, where we'll be studying about semiconductors, superconductors and all, okay. Then comes pico means 10 power minus 2, and femto 10 power minus 15, okay. So these are the numbers, these are the values, and how to convert them. What is 10 power 2 means? 10 power 2 is nothing but 100. So let me write it here. Okay, it's here. So see here, 10 power 2 means 2 zeros. 10 power 3 means 3 zeros. 6 means 6 zeros. 7 means 7 zeros. Then what is 10 power minus 1? 10 power minus 1 is 0.1. 10 power minus 2, 0.01. So if it is plus number, you will see the zeros in the right hand side. Right? If it is minus 1, you will see the zeros in left hand side. Okay, again, if it is 10 power minus 3, it will be 0.001. So the point will go in this direction. Observing this, so remember that how to write them. And conversion are important. Like if I write 1 gram will be equal to how many kg? So we know that 1 kg is equals to 1000 grams. Right. Then if I divide both the side with 1000, so that is 1 divided by 1000 kg is equals to 1 gram. Then 1 gram will be 1000 is nothing but 10 power 3. What is this? 10 power 3. If I take it to the numerator, it will be 10 power minus 3. 10 power minus 3 is 0.001 kg. So like this, you must be able to convert the things whatever they give. Is it clear? Is this clear? So as I said, whatever may be the question, whatever may be the conversion, you must be able to solve it. So this is important while solving complex problems. So the simple things are important. Okay. We think that something is difficult, I'm unable to do it. But that is about the simple things what we are discussing. Clear? Is it fine? Okay. Shall we proceed then? If you have any question, any doubt, you can just ask that. Clear? Okay. Moving forward to the second concepts of measurements. Okay, still now we were speaking about the units, SI units, such standard SI units, right? But now we are entering to the section of measurements. Okay, as I said, length and the mass and the time have standard SI units. That is meter, that is seconds, and the and kilogram, right? So, but in the physical world, in this practical world, we are not only measuring the distance that exists in meters, not only in femto, deca, or any meters, which are extremely big. Okay, so you can consider an astronomical unit, which is given on your screen. You can just refer here. Okay, so what is astronomical unit? Let me just underline here. Okay, astronomical unit. So what is astronomical unit? The distance from the sun to the center of earth is called as the astronomical unit, and it's not a small number, it is very big. So instead of saying it as 1.49 into 10 power 11 meters, we'll directly jump it into one astronomical unit. Why, ma'am? We could have said it 1.94 into 10 power 11. That was okay. Why we want to convert into astronomical units? Because consider planet which is outside the solar system in the Milky Way galaxy. So the distance between the sun and earth is this much. So what will be the distance between that planet in present outside the solar system and our earth? So what will be the distance? So more complex calculation, 1.49 into this many times these much things. So instead of that, if I know the distance between sun and earth is 1 AU, that is nothing but astronomical unit, then I can consider how many AUs are the distance between the planet earth and some other planet X, right? So astronomical units, I can tell any around, yeah, 50 astronomical units, 100 astronomical units. So directly we can compress it, right? So then we have light year. So what is light year? Light year is the distance traveled by light in 1 year. Okay, the distance traveled by light in 1 year is called as light year, and its value is 9.67 into 10 power 15 meters. Okay, and in this, as I said, in this physical world, there are very small distances that you cannot imagine, you cannot see. That much of small distances also exist on the earth, right? In the power of 10 power of minus, and large distances like this also exist. So what is one light year? If you want to know it, so one light year will be equal to 9.467 into 10 power 15 meters. Is it clear? Right? Is that clear to everyone? Okay, done. So this is about the distance. Okay, any questions? Any doubt? If you have, you can put it in the comment. You can see me, right? Am I clear? Shall we move? Yes. So these are nothing but the measurements. So it's not needed that you should remember every value here, but you should be aware that in the physical world, there exists the smallest distance as possible as 10 power minus and largest distance as 10 power 15, 11, etc. So you should know that. So this is for that purpose. Okay. Shall we proceed now? Am I clear? Done. Okay. So let's move to the next thing, that is about mass. Okay, not only the distance but masses also exist in very varied region. So what I mean by that is mass can be small as a Planck's constant. Okay, you'll get to know about the things. You can consider atomic mass unit, not astronomical, atomic mass unit, that is called as 1 AMU, and its value is 1.66 into 10 power minus 27 kg. You can imagine how small it will be. Okay, the masses, it's not 1 kg, it's not 0.1 kg, right? 10 power minus 27, nothing but 0.0000027 times. So you can imagine how small mass we are talking about. Okay, not only these small masses, but also if you consider the Chandrasekhar limit, it is 1.4 into 10 power into the mass of sun. And what is the value of mass of sun? It is 1.9891 into 10 power 30 kilograms. So again, what is 10 power 30? After 10, you should put 30 zeros. So imagine how big is the number, to just to imagine. Then how heavier will be the objects, right? So it's beyond our imagination that exists. Yeah, is that clear? So mass, length, or even the time can be as tiny as very 10 powers minus 27, what you can see about mass, and it can be more as years, billions, trillions. So the numbers are less to speak. Okay, I cannot put it in my words. So they are that varied, that exist. Okay, then, and time, to measure any time interval, we use atomic clock. Atomic clock is nothing but which measures very small units of time, like milliseconds or very less than that too. Okay, microseconds and all. So that is called as atomic clock. And you can consider a long time is the creation of universe. So the universe has been created long back years ago, right? So that is the largest time which you can consider. Or the radioactive decay which happens very slowly for years and ago, right? Measure of big time. And small time like constant, we come across that afterwards. So that are units of small and very big also. Is that clear? Okay, fine. Shall we move forward? Okay, so this is the varied region that exists in physics. Moving forward, the next concept we have about errors. And yeah, till now, we have completed a varied range of basic concepts. If you have doubt anywhere, you can just ask it. So, after this introduction of units and measurements, we are entering in the chapter in the concept of errors. Okay, so when we measure the things, there will be errors, different kinds of errors. What are they? How to calculate them and how to solve them? We are going to study it now. Is it clear? Right? Am I clear? So, errors. After that, we'll go to the significant figures and then dimension analysis. So, these three concepts are left. So, let's clear here what is error and then let's move forward. Okay. So, yeah. Speaking about errors, generally here we are telling about three kinds of errors. One is systematic error, random error, and least count error. So, what are they? Let's discuss them one by one in detail. So, if I want to speak about systematic error, so systematic error is nothing but error in one direction. One direction is nothing but by one cause. Okay. So, in systematic error, we come across three types of errors, that is, instrumental error, imperfection in experimental technique, or personal error. So, let me clear you what is this. So, in systematic error, which is that may happen generally by our wrong instruments, wrong method of finding the answer, or maybe personal error. It's our error to see the things right. So let me explain it in more detail. So instrumental error is nothing but defect in the instrument. If the instrument is itself not right, okay, if the instrument itself is not working properly. So for example, you can see on your screen. So we have a thing which measures the pressure, right? So in one thing, the last, okay, the higher limit will be 40. Okay, the final limit is 40, but in the second compass it is going beyond 40. But that shouldn't be happening, because the maximum limit of that thing to measure the pressure is 40, but the arrow is moving over range more than 40. That means that there is a defect in the instrument. Okay, by using that least count we can correct the defect. Okay, we'll study about it in later, but as of now just know that if there is any problem, any error in the instrument itself which we are using to measure something, so that is called as instrumental error. Okay, so consider simple example. I have a tape here. I want to measure the length of the table. Okay, in that tape, I myself I have written the distance. Okay, that tape does not have the measure of centimeters. I myself I'm thinking and I'm making some centimeters. So is that accurate? No, it's not the right device. We can say that there is a device in the instrument, there's an error in the instrument what I'm using. Okay, that is one instrumental error. The second one is imperfection in experimental technique or procedure. So in Ohm's law there is a procedure. Okay, so with the example what you have studied in your 10th standard, let me explain you imperfection in the experiment. Okay, if I'm performing experiment to prove Ohm's law. So from according to Ohm's law, we know that to perform the experiment, I want a battery, I want a bulb to see that it will glow or not. Okay, so I want a ammeter to increase the value of, yes, current, and find is this true or not. I want to find, right? I want to find that is I directly proportional to V or not. So this experiment I have to perform. But if I mismatch the what a technique, okay, according to this Ohm's law technique I should use ammeter in series, but I am using voltmeter in the series and I'm connecting ammeter in parallel. So now is there any defect here? Is it defect in the instrument? No, it's not the instrumental defect. It is the defect in the technique. I am using here wrong technique to find this. Right? Or else we can consider examples which are normal, right? Just technique is changing. The method which you are following to find that is not right. Understanding what I'm saying? So that kind of errors are called as imperfection in experimental technique or procedure. Clear? Then we have random errors. So what is random errors? It is just you don't know, sometimes suddenly you get a error. It is called as random error. So how we can get a random error? I'm working on something. There is sudden increase in the temperature and there is breakage of device. So it's a random error. So sudden fluctuation. Or I'm doing a Ohm's law. Okay, I have the instruments proper, I have the method also proper. Okay, but what I'm supplying the voltage, suddenly it got increased and the wire got burned. So this also causes error. It's not that wire should get burnt completely. If that creates some defect in the instrument, sudden increase of voltage, if it causes defect in any instrument, it will give me wrong results. Okay, that kind of errors are called as random errors. So personal error, I just left it, so let me tell you. So what is personal error? For that example is a parallax method. So what is this parallax? If when you perform these experiments in the lab, you'll understand this chapter in more detail. Okay, practically you'll understand this chapter in more detail rather than studying it as a theory. Okay, here there is a point. If you're seeing this point from here, you may see it as a different way. If a person of you, your friend is watching from here, he may perceive the point as different than the person who is standing here. Okay, these kind of errors is called as parallax error. It's nothing but the by the point of view from where you're viewing the point, the you see the error. Okay, so you can just take any scale. Okay, take a scale, keep it front of your eyes and just look at it. So measure, you point one. Okay, 0 1 2 3, it will be there on the scale, right? So if I have, I could have tried here. Okay, let me check, do I have it? Okay, yes, I do have. No worries. So just keep it point the one from any tip of the pen or pencil, and then sorry. So then you can just change your position, take it some sideways, and then see, is the point similar, right? Is it pointing the same thing? Just try it out and tell me it your response in the comment. Okay. So that's about personal error. Next, moving to the least count error. So before knowing what is least count, least count error, let's understand what is least count. So the smallest value that can measured by an instrument is called as least count. And I have already solved this kind of question in your 10th standard, that electricity chapter. Okay, so about voltmeter, when we were seeing, so it points a particular direction. So here there is 0, here there is 15, right? In between them there are 10 lines. So what is the least count here? Least count is nothing but the first point, what value it is showing, right? How we did it? Just upper limit minus lower limit by number of divisions, which is 10. So what is the least count of the instrument? It is 1.5, right? So this is what the least count is. And error in the least count. So weak quiz, as of my knowledge, I'm not doing any weak quiz today, right? So I cannot provide you any information regarding that. So lectures are going on, classes are going on, but I don't think any week quiz you will be getting today. But you'll be having the continuous classes in today's session. Today, okay, there will be classes running on. Errors with the resolution of instrument. Resolution nothing but this is not pointing here with a particular time. So this is called as least count error. Error in the least count. Clear with this? Is this clear? Yes, done. Tell me quickly, is this clear or there is any questions? If you have any doubts, you can just put it. Clear, right? So yeah, if that is clear, let's take a quick break and I'll be back after the break. So just be going through the concepts, okay? So next we will be starting with the some standard errors that we have to measure. Okay, this is just a knowledge about error, but next we will be calculating how to calculate the errors. Okay, let's take a quick break. I'll be back after that. Okay, then let's continue our session. Mm, what happened? Let me just wait. Can you see me properly? Now it's proper. Right. So, yeah, you can see the slides properly. And yeah, yes, Ayush, hello. Where is ma'am? Ma'am is here back. Okay. 15 by 10. Yes, it's also right. Actually, right. What is the value of you'll get if you divide 15 by 10? It's again 1.5, right? So why I am using this 0? Because in the instrument, if instead of 0 it is 1 here, then the all calculation changes, right? So for that purpose, only that much. Clear? Shall we move then? Okay, let's move then. Let's move forward. Okay. So now speaking about absolute, relative and percentage errors. So this is a general errors. We spoke that it happens by our mistake in the defect in the instrument or our calculation or the way technique which we use. So this was a type of errors. But next what we are discussing is how how to find out what's the error. Okay, once you have done with your calculation, now you want to correct that, right? So how to correct that errors, that we are going to study here now. Okay, so three kind of error correction we can do. One is by finding absolute error, relative error, and percentage error. So what is this absolute error, relative error, percentage error? Let's understand that now. Okay, so speaking about absolute error, it's nothing but the magnitude of difference between individual measurement and the true value of the quantity. So what is this mean? What this means? So this means that we have to take a mean here, mean error. Okay, absolute error is nothing but we are speaking about the mean value. First thing is how to find the true value of the quantity. If there is some defect, we are getting errors, then how we'll get to know that what is the true value, right? So let me tell that we are measuring a instrument. Okay, so what shall I consider? Let us consider that, yeah. So I'm speaking about first how to find the true value, right? So yeah, see here. First, let us consider. Okay, let's randomly take that I'm measuring a distance, that is A1, A2, A3, A4, A5. I'm getting different measurements. Okay, 5 times I'll measure the difference, the distance, and I'm getting different measurements. So to find the true value, so um yeah. So to find the true value, let me write it as TR. There's nothing to write like this, but just instead of writing true value completely, I'm just using the short form. So what is the true value of this instrument or this measurement is, just add all the measurements what you have done. A1, A2 divided by plus A3 plus A4 plus A5. I'm just adding all the different measurements. Okay, then divided by what is the number, how many times I have did it. Okay, what is the number? Nothing but how many times, n value, 1 2 3 4 5, 5 times. So just divided by 5, or you can consider. So if I say it, okay, let me write it here. Yeah, so if I see it, there are n number of experiments I am doing. Okay, n number of times. So that will be an divided by, instead of 5 at this time, I'll be writing here n. Is that clear? If I do 6 experiments, I'll write 6. If I do 2 experiments, 2, 10 experiments, 10. So this is how the value of n varies, and we'll find out the true value. Okay. Now we got what is the true value. Now how to correct this error is just subtract. Okay, I can call this as a mean also. Okay, if I call this true value as a mean, it will be not wrong, because we are adding and dividing the thing, that is nothing but we are just getting the mean of the thing quantity, right? So let me call it as x mean. Okay, now how to get what is the error. Okay, delta x, I'll call it delta x, nothing but what is the error in this one particular experiment. Okay, that is nothing but the experimental value minus the true value, which is x mean. Clear? So this is to remove absolute error. By doing this, I can find that in my first experiment, what is the value of error. Understanding what I'm telling here? Is it clear? So absolute error is nothing but it gives us the least count of the instrument. Is this clear? Or shall we understand this with an example? So that will be better, I think. Okay, finally what I can do, this is x1 for 1, and I can similarly find x2 for a2 minus x mean. Okay, at last what I can do, delta x mean is equals to delta x of first experiment divide into delta x, nothing but the error in second plus error in third, and so on, divided by how many times I'll measure that experiment. Okay, so that gives me out finally the absolute error. So understand step by step. Just let me erase this and give you the steps, so that will be clear. In the first step, get the values. Okay, measurements. Okay, let me call measurements a1, a2, a3, a4, and all nothing but they are the measurements. I took the measurements. So let me write it also here. What is the measurements I take here? Let me write that. Okay, so yeah, is there any disturbance? Okay, is there any disturbance, noise? Clear? So measurements I'm considering here a1, a2, a3, and let me take it till an. So this is the measurements I did. Okay, what is the second step? Second step is to find the mean of your measurements. Mean of measurements, let me call it as mean A. Okay, so what will be the formula here? Mean of the measurements, I said it as delta x. Change, okay, I can call it delta A because afterwards it will be confusion. So let me call mean as delta A. Okay, first I will find the mean of these quantities, that is a1 plus a2 plus a3 and so on plus an divided by n. This is the mean, right? So second step is done. What is the third step? What is the third step? Take the number measurement minus mean. Okay, measurement measurement minus mean, that is nothing but now I'm calculating the delta x1, x2, x3. Delta x1 is equals to measurement a1 minus the mean a. Measurement x2 is equals to the calculation of x2 minus mean a. Is it clear? So like this till n we will find out. And in the fourth step, the final step, we will find the mean of errors. Mean of errors. So here, what is this delta x? This is nothing but error in one experiment, first reading. Now I want mean of, or nothing but the error present in all the readings. So I call it as delta x mean is equals to delta x1 plus delta x2 plus and so on plus delta xn divided by n. So this is the method. The final error what you are getting here is called as absolute error. Is this clear? Is this clear what I'm telling? Okay, I have broke it into step by step. First I just said you what is there, then now you can properly calculate if there is any number, right? You have to perform step 1, then move to step 2, step 3 and step 4. You'll be getting the final answer. So first thing is measurements 1 2 3, 1.1, 1.2, 0.9, 0.99 maybe the measurements. So what you'll do in the next step, you'll add all the measurements, okay, divided by the number of measurements. So what you got now is the mean of your errors, right? So in the next step, you're going to subtract the mean from the value, that is 0.99 minus 0.1. So what will be it? Minus 0.01. So that is nothing but the error of first result. Likewise, you'll calculate the error of second result, third result, and so on. Finally, what you'll do, you'll add all the, you'll get the mean of all the errors. First error, second error, third error, all the errors, you'll add them divided by the number of experiments or the number of errors. Right? This is the method to find absolute error. Is that clear? It's not as complicated as it is appearing, right? You can just take it. Do it, just you can remember them. It's not as difficult as it appears. Okay. So done with the absolute error, then relative error is easy. Okay. Okay, so okay. Just a second. Here just I want to correct a thing. Absolute error is nothing but measured value minus. Okay. So let me just clear here. Just I have combined these two things. Hmm, let me just erase this. This is not wrong, but I have combined. This is called as relative error. What we are getting here, okay, this error, okay, where it went. Let me just correct that quickly. This error is the absolute error. Okay, only three steps. Fourth step is for relative error. Is it clear now? Any confusions what I'm speaking here? The things that we get by subtracting the measured value minus true value. That is done here, right? Measured value minus true value. So these are nothing but the absolute errors. Absolute error nothing but we are speaking about what is the error in first, second, third, and fourth. In the relative error, we will calculate the mean. Okay, x mean is equals to x1. Okay, this step comes here for the relative error. And so on divided by L. So this is the way to calculate the relative error. Ratio of absolute error to the true value of x. Clear? Then we have percentage error, just taking the percentage of these things. Okay, the mean, if I take out the percentage of this, what it will be? It will be x mean divided by number of trials, that is total true value, into 100. Okay, into 100%. True value, this is the mean what we have found, x mean. Okay, that is relative error divided by actual value into 100% gives us percentage error. Is it clear? Fine. Clear with this? Okay, then. Let's move forward. Okay. Shall we move forward now? So, next concept is of combination of errors. So, if there is one error, we'll be going with these things. If there is two error, three error, multiple errors, if they exist in the combination, then how to solve it, right? So for that purpose, we will be understanding the errors in the sum, product, difference, and quotient type. So what this means, right? So if there is any function, let me write it here. If there is a measurement which is done as A plus B. So two measurements, we are adding it and we are getting our final measurement. And if there is error in A, if there is error in this measurement B, then what we will do, our final result error will be equal to the error in the measurement A plus the error in the measurement B, right? As the measurement comes by adding them, their error also comes to us by adding their individual errors. Is it clear? Is it clear? Tell me. It's as simple as that. If it is subtraction, we will just substitute the minus sign instead of the plus sign. Okay, so what is this? This is a first one. Yeah, absolute error. So what I have wrote here is the absolute error. Let me write it here. This is absolute error. Then what I can do, I can just divide this error with its original value. Delta z by z is equals to delta a by a plus delta b by b. Clear? So I just divided the absolute error with the original values. So the thing we are getting here is called as relative error. So where is the cursor? Okay, it's here. So this is relative error. Okay. Then, so this is how we calculate the relative error. Clear with this? So this was for addition. If the final value we are getting it by addition, this is the process. And difference also same process. Okay, let me write it also. Okay, if it is minus here, okay, if it is minus here, you'll just put minus here and here. Same, okay, both are similar. For the sum and difference, this is the method to calculate absolute and relative error. Is that clear? Is that clear, the method to calculate absolute and relative error? Fine. The next thing is product and quotient. Here the game changes. Okay, it's not same as the addition and subtraction, it is different here. So if I tell that there is a quantity which is in the format of a power n into b power m. So there is multiplication and there are powers also, right? So it looks as complicated, but if I take the relative error, okay, I'm jumping into the relative error of this, okay, not absolute error. So they are in the format of multiplication. So if I take the absolute error, relative error over here, so it will be delta z by z is equals to this power n comes down into a delta a by a, right? After that we can add a plus sign here and m into delta b by b. So this is the quotient, this is the product rule which we are applying here. Okay, is it clear? This is a relative error for the product of things. Okay, so or the raised to the power also you can consider it. Error in case of the measurement raised to a power. So how to calculate it? Clear? Sorry, clear? Now, if it is in the division format, okay, if the error is in the format of division, let me write it here. If z is equals to a power n by b power m, a power n by b power m. So how to calculate this error now? So we can just write it z delta z. Yeah, you can see right here if I write delta z by z is equals to, again n comes down, right? N into delta a by a, okay, plus, so it is same as that of division. It is again a plus sign here. Clear? Okay. Plus m into delta b by b. So let me conclude a thing here by this. So if it is minus also, it will be plus. Okay, let me conclude a thing here that if it is plus or minus, if it is z is equals to a plus b, or z is equals to a minus b, the absolute error will be z is equals to delta z is equals to delta a plus delta b, and the relative error will be delta z by z plus delta a by a, not plus, this is equals to plus delta b by b. Okay, if the error, let me just change the color so we can differentiate the things. If z is equals to a power n b power m, or z is equals to a power n divided by b power m, then what will be the relative error? Delta z by z is equals to n into delta a by a plus m into delta b by b. So this is the method. Okay, so error in case of powers, we have seen it, right? A power m, b power m, a power n, b power m is nothing but they are in the powers. Is it clear till here? Is there any confusion? Yeah, I hope that's clear. Just let me refresh this. Is that clear? Any questions, any doubts? If you have it here, you can ask it. I hope that is clear, right? There is no confusion. Okay. So then had lunch. So let's take a lunch break. After that, I'll be back very soon. Let's take a lunch break. Okay. So just quickly have your lunch. I'll also have my lunch. And let's be back with the next concepts. Till that, stay tuned. Let's have a quick break and I'll be joining back very soon. In a 15-20 minutes, we'll have a break. Okay? Okay. So yeah, did you guys had your lunch? Hi Sampan, good afternoon. How are you? I'm great. How are you? How is the studies going on? Yes, guys, shall we start? Yeah, tell me, shall we start? Can you see me properly? Yeah. Done, had lunch, everyone. I had my lunch right now. Mm. Okay, then let's continue our session. So we are done with what is the concept of units, standard units, how to use them, what is femto, deca, milli, micro, mega units, right? So these concepts are done. And also we have studied about errors, different types of errors, combination of errors, and how to calculate that, right? So these concepts are done and our break is also done. Let me just remove it. Yeah. So then let's move forward. Let's start with what is next. Right. So till here, everything is clear. Hoping that moving forward to the concept of significant figures. So this concept is also important in JEE mains and all. You'll be having numerical questions in physics. They'll be giving you the blank space and you have to, they'll ask you round up to the 3 digit numbers. Okay, in that format you have to write. Okay, so how to do that, let me guide you with that thing now. So significant figures that are nothing but called as significant figures. Okay, I think you have been seeing teachers, and I'll also be whenever we calculate. If I get a number like 6.666, okay, instead of writing these many things, we just write 6.7, right? It tells us by this significant figure. The significant figure tells us to round up the numbers. Clear? So how to do that? How we will convert this thing into this thing? If it is 6 point, okay, let me consider 2 1 8 8. If it is in this format, one thing I can convert it into 6.22, or I can just write it as 6.2. Okay, this both are right. Okay, so why here 2 instead of 1, and why here I skip this 188? So this all things I'll be explaining here. Okay, is it clear? Is it clear why we should learn about significant figures? What is its importance? Is that clear? Okay. So then let's continue, guys. Okay. So starting with the significant figures. What is significant figure? The digit whose value are accurately known in a particular measurement are called as significant figures. When we calculate a number, if I write there's a value called 1.0, here it is not needed, right? Instead of that, I can say 1 is the value. So these kind of calculations are found using significant figures. Okay, so what are the rules? How to find the significant figures, or how to write the numbers in digits in the form of decimal values? We are going to study here. Okay, so the first rule says that if the rightmost digit is less than 5, then it is to be dropped. So, any example you can consider: 6.74. Okay, 6.74. The rightmost digit is 4, which is less than 5, right? We know right? 4 is less than 5. So according to this rule, they are telling us that if the rightmost digit is less than 5, I can just drop it out and I can write 6.7. Clear? Or let us consider another number, 8.2832, right? So here these two digits are not read it as 32. We write it 3.2, okay, 8.2832, right? So this 3 and 2 are less than 5. So I can drop this both the numbers and I can write it as 8.28, right? Because as the numbers are less than 5, I can just drop them out. Is this clear? The first rule of the significant figures. Is that clear? The first rule? Okay. It's simple as that. Moving to the second rule, if the rightmost digit is more than 5, the prior number is increased. The prior to the number is increased by 1. What this means? Let me give you an example. 7 point, okay, 28. Now, this rightmost number 8 is not smaller than 5. It is greater than 5, right? So, at this time, how I should convert it? If the rightmost number is greater than 5, then you have to add the prior number by 1. Clear? You have to add the number by 1. Then what will be the answer here? It will be 7.3. Okay, let's consider another example over here. Let me take here 2.147. Okay, so how to convert this? I'll see this rightmost number which is greater. So I can convert this into 2.1. In the place of 4, it will get plus 1 because the rightmost number is greater than 5. Whenever the rightmost number is greater than 5, we will add the prior number with 1. So it turns out to be 2.15. Now you can ask me, Mom, yes, you have converted it and it got reduced to 2.15. Can we further reduce it? Yes, it's possible with the next rule, right? Just, where is the cursor? Okay, it's here. So, yeah, it is possible. Let me consider now this 2.15. So, what it has given, if the rightmost digit is 5, then the number prior to it is increased by 1 if it is odd. So, there is a condition. So, now in 2.15, 1 is an odd number. We know that, right? So, I can add this 1 and I can make it 2.2. Clear? So if you're getting an answer 1 point, that is 2.15, you can convert your answer into 2.2, just in a two digits. Okay, if instead of 2.15, if it is 2.25, then what will be the answer? See here, if the rightmost digit is 5, yes, it's 5, right? Then the prior number to it is retained by 1, okay, or it is retained as it is if it is even, okay? There's a mistake, not a mistake, just it's not 1, it is retained if it is even. Now 2 is a even number. I'm going to retain it, but I will drop this 5 and I can write the answer as 2.2. Is that clear? If this is 6, if this is 2.6, I will go to the first method, greater than 5. And what it tells, if the number, okay, second one, greater than 5. If it is more than 5, add 1. So it will be 2.3. Okay, if it is 2.26, it gets 2.3. Clear? And let's consider some more examples. So if it is 2. 15? Yes, Gokul. Yeah. If it is 2.15, it becomes 2.2. Okay, now let's consider one number less than 6, that is 2.24. If it is 2.24, I can convert it into 2 point. I'm just going to drop this number, and the prior number to the right number will stay as it is. What for 2.25? It is 2.2. Here you can see it, right? This one. For 2.25, it is 2.2, because 5 is a odd number. If the rightmost digit is equal to 5, you should use these two rules, and you should see the prior number. Prior number is a even number, so I'm just keeping it as it is, and I'm going to drop 5. Is that clear? Any question? Any doubt? If you have any doubt, you can ask that. Is there any doubt or clear with this? Tell me quickly. So this is called as actually rules of approximation. Okay, how to appropriate the things, right? So we can just write it as 2.25 is appropriately equal to 2.2. Likewise, okay, it is how to appropriate things. And shall we move forward then, if it is clear? If it is clear, let's move forward. Okay, it is applicable for 2-digit and 3-digit numbers with decimal. Yeah, with the decimal numbers, not only 3, if it is many also. Not only 3. Okay, but yeah, for the points, for the decimal things, which has decimal, they are applicable to them. Okay, so if I give you a question, 4.28315. Okay, now reduce this into 2-digit number. Can we do this? Reducing this number into just 2 digits, what will be the answer? Quickly try and tell me the answer. Anybody who is watching the video can answer this. So what will be the answer here? Yes, what is the answer? Can anybody tell this quickly? So one by one we have to approach this. Okay, so I will go to the rightmost number. I can see it is 5. If it is 5, I will see the prior number. The prior number is odd, and if the prior number is odd, we have to increase the prior number by 1. So it will get converted into 4.2832. Okay, next I will check this number. It is less than 5. I can just drop this number. I'll check this number. That is also less than 5. I will just drop this number also. Then I can see there is 8 here. Yeah. Do anyone want to answer this? It's done. Do anyone want to answer this? Yes. So now the rightmost digit is more than 5, and we know that if the rightmost digit is more than 5, then increase the prior number by 1. So finally the answer will be 4.3. Okay. So this is the answer. I have converted these many digits number into just 2 digit or a 1 digit number, you can call it. Clear? Okay. Clear with this? How to find the digits, how to round off the number. Completely cleared now. Good. Great. That's good. Now let's move to the significant figures. Actually, what we have discussed here is how to round off the numbers. Okay. But if in a question if you will get like how many significant figures exist in a particular number, then how to find it? So here there are some examples. In the A, it's given that there are 4 significant figures. In A, it has been given 5080, sorry, 8.0, right? So it said that that has 4 significant numbers. So what is the rule of counting the significant numbers? We should know that first. Okay, so the first thing is, so all the non-zero digits are significant figure. So first thing is all non-zero numbers. All non-zero numbers are significant figures. So 5 is a significant here, 8 is significant. So we got 2 significant figures. Okay, let's keep them and let's see one by one. All non-zero numbers are significant. So here also there are 2 non-zero numbers. Here also 2 non-zero numbers, and here also 2 non-zero numbers. Then what's the next point? All the zeros present between non-zero digits are significant. So listen it carefully. All zeros between non-zeros are significant. Between non-zeros are significant. So with that, this is a significant number. This exists between, so it is a significant number. We have not spoken about decimal values. Let's keep it as it is. And this is a number between significant figures. So it is a significant one. Okay. One first thing is all non-zero numbers are significant. All zeros between non-zeros are significant. Okay. What's the third rule? Okay, this was about the two rules. All the zeros to the right of non-zero digit without a decimal point are not significant. All the zeros without, just speaking about without the decimal point, right? So I can consider these 3 zeros as non-significant figures. Okay, so remaining are these three significant figures. So we can see that here. So what is the third point? All zeros after non-zero, not in the middle, after non-zero are not significant. Zero are non-significant. So let me write it. This is non-significant, this is significant, and this is for significant. Okay. So with that, we can remove anything here. So here we have point. It is speaking about not decimal points. So decimal points are not included here. This also has a point. This has a point. So we cannot go to that. Let's go to the next property or the next rule to check the significant figures. That is the fourth rule. That is, if the number is less than 1, nothing but 0 point something. So are there numbers like that? Mm, are there numbers which are less than 1? So we don't have that. Okay. So let's see. if the number is less than 1 in the form of fraction, all the zeros to the right of decimal point and to the left of the first non-zero digit is not significant. Okay, let's not dive into there right now. Afterwards, I'll be explaining that. Let's move to the next point. The next point says that the trailing zeros in the number with the decimal point are significant. The trailing zeros, the zeros that come at the last after the points. Okay, that means that here there is a point, after the point I have a number here, so this is also significant, so I'll get four significant figures. So zeros tailing after point, after decimal point, okay, are significant. So this is after decimal point, this is also significant. And yeah, these numbers, this zero and these zeros are also after the decimal point, so they are significant. So 1 2 3 4 5, so we'll get five significant figures, four significant figures, right? So and we have to discuss about this, right? So the next point that comes is power of 10 are not significant. So the power of 10 is not significant. Clear? Power of 10 is not significant. Power of 10 is not significant, and zeros tailing after the point, decimal point, are significant. And the sixth thing is what we have left, that was if the digit is less than 1. Okay, yeah, all everything is discussed now, right? So if the digit is less than 1, I have just skipped that because we don't have here that example, right? So at that time, what should be the significant figures? So let's consider an example of 0.00. Okay, let's consider 0.003580. Okay, 3580. This is tailing after a point, so this is significant. These are non-zero numbers, so this is also significant. And what we have studied, the zeros that exist after the point are significant, so these are also significant. What about this zero? Is it significant or not? Is it significant or not at this particular time, at this particular point? Okay, these zeros, let me just write that out properly. So when you get a number which is less than 0, which is less than 1, you will not consider 0 to be significant. You'll just consider the digits and 0 that is present between them. So we have three significant numbers here. Okay, significant figures or significant numbers, you can call them. Is it clear? Tell me quickly, is that clear how to calculate how many significant figures exist in a number? Okay. Shall we move forward now? Right? So right after significant figures, we have decimal dimension analysis. Okay. The most important part of this session is about dimension analysis. After that, we'll be solving some of the questions, right? But this is important to get good marks in your exams. Fine. Shall I start with this? So, is it possible to zoom? Yeah, we can zoom it. So, this is the last concept what we are studying here. Okay. Yeah. This is the last concept we are studying here. So, what is dimension analysis? Dimension analysis is nothing but taking a standard thing and measuring any quantity. If I say it, you'll not understand that clear. Let me just write here so that will be clear. So, see here, it's given length is represented with a capital L for the dimension analysis, and mass with capital M, and time with capital T. Let's consider only these three quantities, not the rest things. I'm going to explain here. Okay, so look at it. Okay, let me explain it here. So now if they ask me to calculate, so let's not use here. Sure. Okay, if they ask me to calculate what is the dimension of force, okay, what is the dimension, find the dimension of force. Okay, yeah, let me just solve this. So I know that force formula is F is equals to ma, right? Okay, so mass is represented with capital M, as we know. So I got to know the dimension. It's written in square bracket. If I'm finding the dimension, I should write that quantity in square bracket. Okay, the dimension of mass is M. Now I want to get the dimension of acceleration. I don't know that. I just know the dimension of length. The dimension of length is L. Dimension of mass is M, and the dimension of time is T. Okay, I just know these quantities. Okay, so now I also know that, and acceleration is nothing but velocity by time, and velocity is equals to distance by time. Can I find the dimension of velocity first of all? If I want to find the dimension of the velocity, it is nothing but distance by time, right? Distance is measured in terms of length by time, right? So if I take this t upward, it will be L t minus 1, right? Because it is inverse. It was in denominator. I took in numerator. So it is for velocity. Now let me find the dimension for acceleration. So the dimension for acceleration will be dimension of velocity divided by time, right? So the dimension of velocity is L t minus. Okay, t minus 1. This is the dimension of velocity. And what is the dimension of time? It is t, right? Again, I'll take this t in the numerator. So I'll get L t minus 1, this one, plus this one. That turns out to be again a minus 1 here. Same base add index concept. So what is the dimension of acceleration then? The dimension of acceleration will be L minus t power minus. I got the dimension of acceleration. I'll just substitute here. And finally, I can find the dimension of force is nothing but m L t minus 2. So let me now check, is my answer correct? Is my answer correct? M L t minus 2, and you can find it here, m L t minus 2. So it's not necessary. You should keep this all dimension formulas in your mind. You should remember them. If you know the standard things, rest of the things you can derive. Okay. For temperature, theta is used. For current, I is used. Okay. This important things, if you remember, all other quantities you can derive with the help of the formulas. Clear? Yes, tell me quickly, is that clear? So, how to find the dimension of the given things? So, there's a definition given over here. Let's read out what it is. The dimension of a physical quantity are the power to which the fundamental units are raised to represent of physical quantity. Okay, nothing but in a bracket with a power, we'll be representing it. The process of analyzing the dimension of a physical quantity, principle of homogeneity of dimension, is the termed as dimension analysis. So what is dimension analysis? We are analyzing the numbers, we are analyzing the terms. It's SI units basically, right? We are measuring all the quantities in terms of standard quantities, which we have started in the first. Derived quantities, fundamental quantities. We are writing the derived quantities in the dimension of fundamental quantities. I hope that is clear now. Right? Is that clear? Shall we move? Right? Shall we move forward and find out some of the application of this dimension analysis? So we have good applications of this dimension analysis. Let me solve it now, so that you'll understand why this is important and how we can use it. I wanted to try a formula here. Let's do that. Yeah. Let's consider an equation from ninth standard physics. Okay. I'll be considering a equation from ninth physics. And we'll see that how dimension analysis helps us. So in ninth standard physics, the first law of motion you have, that is V is equals to U plus AT, right? So we are going to prove this by dimension analysis. So what is the dimension of V? Let's first see that. Is okay, this question, this is true, you know that. Okay, in your examination you'll get some equation. Check whether, okay, if you get the question as check whether the equation is true or false. Okay, if you get the question as check whether the equation is true or false, you already know this equation, so you can tell this directly, yes ma'am, it's true, we have studied it in the ninth standard. But consider there is some complex equation which you don't know and you have to prove it. At that time you will be using this dimension analysis. So what is the dimension of V? V is nothing but, again just remembering you, V is nothing but velocity, that is distance by time. Distance means length and time means t power minus 1, right? So this is the dimension of velocity. So let me mark this as equation 1. Okay, I'm just marking this equation as equation 1. And let me consider this part now. Okay, so this was LHL. Now let us consider the RHL, right hand side of the equation. Or you can do directly both. I'll also be saying you, but as we are doing it for the first time, I'm just keeping it separate. So it is dimension of U plus dimension of A into dimension of T. So what is the dimension of U? It is also velocity. So the dimension of U will be L into minus T. Agree with this? Yeah, dimension of V is L into minus T power minus 1 plus dimension of A. What was the dimension of A? Just we have found it out, right? Dimension of A is L T minus 2. So let me write it here. L T minus 2 into what is the dimension of time? It is just T. Let's solve one by one. Let me first keep this as it is. If I multiply these two terms, so L is there. Same base, add index, nothing but minus 2, minus 1, right? So minus 2 plus 1, right? So again I am keeping this same, L T power minus 1 plus L T power minus 1. Is it clear? So the final answer is 2 times L power T minus 1. So this is equation 2. Okay, this is equation 2. Now compare the equation 1 and Do you find any similarity between them? You can say it, ma'am, there is two, right? Two is nothing but a coefficient, a constant quantity. I can say that I don't want two, right? I'm just comparing here L t minus t power 1 minus t inverse and L t inverse. So these quantities are same, nothing but this equation is right. I'm not worried about this constant quantity because I'm just checking the dimensions here. So the dimension is same. So the answer is right. So is it true or false? It's true. How? By the dimension analysis, we have proved this. Is that clear now? Tell me quickly. If you want to take do this for the equation such as s is equals to ut plus half ad square or v square is equal to u square plus 2as, you can perform it for that and you'll get similar kind of results. Whatever may be the coefficient, but the dimensions of the equation will be same. Is it clear? So you can try it. If you want, I can solve them. So yeah, I have the space, I can solve them, but I'm trying to get some complex questions. Okay, the easier one you can do it, right? Shall we take one complex question here? It will be nice, okay, solving these kind of questions. We can take a time period equation or centripetal force equation. Time period, it is t is equals to 2 pi into root of L by A. Okay, or the centripetal force equation, which you already know, that is F is equals to mv square by r. Right? We can do any of the equation. Let's go to the centripetal equation, as that you have studied it in the 9th standard itself, in the gravitation chapter or in the chapter of motion, right? Circular motion we have studied there. So I'm going to take it. I'm not going to take your time period as you have not studied it yet. So let me write the question first and then we'll solve. So what's the question? In the question it is given force, centripetal force is equals to K into m power x, okay, v power y and r power z. Okay, so they have asked us to find the equation. Find the equation of centripetal force by dimension analysis. They just gave us this. They didn't said anything. Now we have to calculate what is the power x, what is the power y and what is the power z. So let's start at solving this. Okay. So first let us consider the dimension of force, right? We are considering the dimension of force. So what is the dimension of force? So this equation is nothing but, let me just split them into the words. That is force is equals to K is a constant into mass power x into velocity power y into radius power z. Okay. So yeah, how to find it now? I know the SI unit of force. So let me consider the SI unit. I'll just keep the K as it is. And what they have given, mass power x, velocity power y and radius. I can write it as, yeah, let's keep it as it is. Radius power z. First step, I just introduce the brackets to show that I'm applying the dimension analysis. So now what was the dimension of force? You can calculate it, or let's now get directly ml t minus 2. We have already calculated it here, right? ml t minus 2. I'm going to substitute it here. ml t minus 2. ml t minus 2. Okay, this is done. K is nothing but a constant, just keeping it as it is. Then we have mass. Okay, mass is written in the format of m power x. What is the dimension of velocity? What was the dimension of velocity? L t minus 1. So the dimension of velocity is L t minus 1 whole power y, because v has the whole power y, so the dimension of v will also have the power y. Then what is radius? Radius is nothing but a distance that is measured in terms of length, so length power z. Clear? So see, so simple it is. See here, m l t minus 2 is equals to k times of, now I'm going to combine this equation, m power x, l power y, t power minus y, and l power z. Tell me, is this step clear or not? Because this step is important. What I have did, so if you want to get it more simpler, let me just add another one step here. So it is k into m power x. I just took it inside the bracket, and there is L here. I'm taking y inside the bracket, so L power y. T minus 1 is there, again introducing y inside the bracket. Same with here. Okay, I've just took the powers inside the bracket. Now, as usual, let's keep k as it is. There is only one m power x. So L I can see, y, z. Same base, add index. So it is y plus z. And t power is minus y. Only one term, which is equal to m l t minus 2. Now both are in the same format. So I can compare their powers. Okay. So I can comparing the powers. So if I compare the powers for m, what is the power for m? In the right hand side, it is x. Okay. And in the left hand side, it is, if there is nothing present here, it means it is 1. So the value of x is 1. Okay. And here with the t, I'm comparing, right? T power is minus y, and here it is minus 2. So I can write it minus y is equals to minus 2. If I cancel minus, what is y? Y is 2. And what is the power of L? Yes, I can just add them, x plus y. So it should be 3, right? Or I can write it as, okay. So it is y plus z is equals to, right? So how much it is? So we got y is equals to 2, x is equals to 1. And the power, is it fine? Let me just check it out. Yeah, that is fine. So it is turning out to be 1. That is y plus z is equals to 1. Okay. Y plus z is equals to 1. Then if I want to find out the value of z now, right? So z will be equal to 1 minus y. So 1 is here, y is 2. So what is the value of z? Z will be equal to minus 1. Is it clear? So this is the method of dimension analysis, how to analyze the dimensions. So now if I substitute it in the given equation, let me take some other color here. Okay. So it is given f is equals to k m power x. X is nothing but 1. I will just leave it as it is. Into v power y, that is 2. Into r power is minus 1. If I arrange this equation, f is equals to k into mv square by r. This is nothing but the equation of centripetal force. Yes or no? By the dimension analysis, we have derived the centripetal force equation. F is equals to K into mv square by r. Is this clear? Right? Tell me quickly, is this clear? Fine. Okay. Done or not? Understood or not? Okay. So we are done with the session. The theoretical explanation is completed here. If you want to solve some of the questions, we can solve that. Before that, let's have a very quick break as the explanation part is completed. The rest things are question answer. So some 8 to 10 questions I have added. We are going to find the answers for that. Before that, just recall all the concepts that we have studied in today's session. So the concepts of units and measurement chapter is done here. Okay, let's have a quick break. After that, we'll go to the question answer part. Fine? Done? Great. So let's continue with our questions. I hope today's session was clear. So all the concepts related to dimension analysis, SI units, and measurements are covered in this session, right? So we have already discussed all the concepts that are present here. Shall we move now with the question and answer session? Yeah, shall we proceed? Okay. So let's move. Let's start today's session. What we have discussed. Let's proceed with that. Okay. So the first question is on your screen. And what is the first question? 10 divisions of a main scale of vernier calipers coincide with 11 divisions of vernier scale. If each division of a main scale is 5 units, the least count of the instrument is. So before answering to this question, you should know what is vernier calipers. Okay. So vernier caliper is nothing but an instrument, a device first what you'll be using in your first lab. Okay. In the first lab, your lab teachers will be guiding you with the vernier calipers, okay, and the screw gauge after that. So, what is vernier calipers? It is nothing but used to measure the dimensions such as length, breadth, and height of a block kind of structure. Understanding what I'm saying? So, vernier calipers is an instrument that is used to measure length, breadth, height of a block shaped structure. So, here it is given 10th division of main scale. So, how will be the structure of vernier caliper? If you see it, it will be having a main scale over it. Okay, it will be having one main scale and the other one as a vernier scale. Like this will be the structure of vernier calipers. In main scale, it is telling that the 10th division of main scale, let's consider this is the 10th division of main scale, is coincide with the 11th division of vernier scale. So if you see this, it is coincide with the 11th division of vernier scale, right? If each division of main scale is 5 units, each division of main scale, so one division of main scale is equals to 5 units. Okay. The least count of the instrument is, least count is nothing but the first number. Okay, the first division, what value it carries, right? If this coincides with the 1, then what units, how much number is that, we have to calculate here, right? So how to do this, you can see here there's a big explanation. So let's read out. The least count of vernier caliper is the smallest measurement that can be obtained with it. So as I said, it is the least number what we can get, and it is determined by the difference in the measurement of main scale and vernier scale. So if vernier main scale is showing 1 here, and what is the number of vernier scale that is coinciding with that one digit is called as the least count of vernier caliper. Okay. Okay. In this case, the 10th division of main scale coincide with the 11th division of vernier scale. It's given in the question. This means that 11th division on the vernier scale is equal to the length of 10th division. Exactly, because they are coinciding, that is nothing but it is showing 10th position in the vernier scale and it is showing 11th position. Sorry, in the main scale it is showing 10th position and in the vernier scale it is showing the 11th position. That means the both distance are exist at a same point, right? So both have same distance. Since each division of a main scale is equals to 5 units, this means that 10 divisions will be equal to 50 units. They have given that if this is 0 and if this is 1, in between this there are 10 units. Okay. If between 1 and 0, sorry, how much it is? 5 units, not 10, 5 units it is given. Just a second. It is given that between 1 and 0, there are 5 units. Okay, then what is the units between 1 and 10? For 1 and 0, it is 5. 1 to 2, 0 to 2, it will be 10. 0 to 3, 15. 0 to 4, 20. 0 to 5. Okay, getting what I'm telling? Okay, let me. For 10 divisions, for one division, 1 into 5, that is 5 units. For 10 divisions, it will be equal to 10 into 5, which is 50 units. So what is the least count of this vernier? How many digits? Okay, what is the difference of numbers? It has in between this 50 units. So 50 units exist in a main scale. So I'm talking about main scale between 0 to 10. Clear? Between 0 to 10, there are 50 units. Okay. The length of 10 division on a main scale is equal to 50 units is their division on the vernier scale. This means that one division of a vernier scale is equals to 50 units by 11. Why? Because the one digit of vernier scale, we don't know where it is, right? This is 0 of vernier scale. So the 11 is here. I'm drawing the vernier scale now. So the 11 is here of vernier scale. But where is 1? We don't know that. So how to point out that where is 1? It is nothing but the total number of divisions, that is 50 units, divided by vernier scale marking, that is 11. So 50 divided by 11 is the one division. So where is 1? 1 is at the point 50 divided by 11. What is the value? Whatever the value we get, it is pointing at that number. Therefore, so if we calculate the least count of the vernier scale, it will be equal to the value of one main scale. This one, it will be equal to this 1 unit, right? Minus value of 1 unit in the vernier scale. So yeah, it's a bit complicated, but don't worry, we'll calculate it. Okay. So 5 units on a main scale, that is nothing but 5 units gathered together, they form 1 unit, or I can say 1 meter. Let's consider to keep it simple. If I say this also unit, this also unit, you'll get confused. So I'll can conclude that 5 units is equal to 1 centimeter or 1 meter. So that 5 units minus 50 by 11, the unit of vernier scale, 1 unit of main scale is equals to 5 units. 1 division of vernier scale is this much. Now can you understand? 1 division of main scale is 5 units. 1 division of vernier scale is 50 by 11 units. When you subtract these things, the whatever the value you are getting is the least count of the vernier scale. And yeah, they have asked us to calculate the same, right? So the answer is 5 by 11, option A. Clear? Okay. Next is the dimension formula for angular impulse. Impulse is nothing but large amount of force in a short interval of time. So they are asking about angular impulse, right? So here the concept changes. Here the torque comes into the picture. Instead of force, if it is an angular thing that is going on, so we call it torque. Torque is replaced instead of force, right? So large amount of torque we can say. So what is the dimension formula for a force? We have already seen this, ml t power minus 2. So what is torque? Torque, you should know this formula. Torque is represented with tau is equals to F into R. Right? R is length. So what is this? This is the dimension formula for torque. So what is impulse? Impulse is large amount of force in short amount of time. That is nothing but tau into R. R is the distance. Sorry, large amount of force in short amount of time. So time is T. Understanding what I'm telling here? So see, first you should know what is impulse. Impulse is nothing but large amount of force in short interval of time. But here they have given angular impulse. So instead of force, we will be considering tau, that is torque. Okay. And what is torque? Torque is nothing but force into R, FR it is called. And what is the dimension of force? It is M L T minus 2, right? And we have R, nothing but length, so L. So what is the dimension of tau? Dimension of tau is, that is nothing, torque is 1 L M L square minus 2. Is that right? Exactly. Then we want the angular impulse, right? So the formula for angular impulse is large amount of force in short interval of time. So what is tau? M L L square t power minus 2 and time t. So what will be, finally we'll get M L2 t power minus 1 plus minus 2, see here, minus 2 plus 1, right? So it gives minus 1. So what is the right answer here? It is option C, right? Option C is the right answer. Moving forward. So radius, length and resistance of a wire is given. The percentage error in the resistivity of the material. So we know that R is equals to, that is resistance is equals to rho L by A. They are asking for resistivity. So resistivity is equals to R into A by L, right? So I have told you how to calculate the percentage errors. So there is, L is, the error in length is 0.2, error in resistance is 10 and error in the radius. Okay, so they have not given directly formula of A. We know that A is equals to pi r square. So pi is constant. I'll just keep it aside and I can write r square by L. Okay, so now it's fine. So how to do this? First we will calculate the percentage error. Nothing but 10 divided by 100 into 100. So that gives 10%, right? So the percentage error in the resistance is 10% and the percentage error in length, okay? Because this is taken in the denominator. Out of 15, 0.2 has error, right? So 0.2 divided by 15. So how much it will be if we calculate the length? So when you divide this, you'll get the equation 1 point this. First you have to convert this. So how to do this? Percentage error. What is percentage error? Percentage error of some quantity x is equals to this error quantity. So I can write it delta x, which is error, by original value into 100. So don't get confused. This is into, this is original value, this is error, this is the percentage error. Clear? Okay. After finding this, so A means, as I said, we want square and pi we will be having. So if I square this R, right, 2 times, square is nothing but 2 times, because in dimension analysis, in the method I have taught you, right? So what example we took? It was AB. A power n and B power m, right? So at that time we reduce this as in this format, right? So here also r square becomes 2r. This I have already taught in this particular session how to convert this. If it is a power, it comes to the, it comes to the surface level, it comes down. Okay, so the same thing is going on here. Then you can calculate what is the error in R. Similarly, you'll add all the errors and the final error is the total error in the instrument. Okay, so the measured value of length and simple pendulum. Okay, so simple pendulum formula, if you know it's good, if you don't know, it is to root of 2 pi into root of L by G. So this is the time period of simple pendulum. So it's given the measured value of error analysis. I didn't found that. Is it? I did not found it. I'll check it whether if it is. So if you guys know, you can tell me that. I have gone through the syllabus, but we can check that out. Is that related? I should check it once. I have gone through the syllabus just on the surface level. Mm, I'll check that and I'll let you know. Okay, I'll check that later and I'll let you know because I am not sure about that. In the book itself, it's not there. Okay, so we'll see for that. Okay, if it is removed or what, I'll see for that. Fine. So, these kind of questions will be solving here. I'll check for that. What's the reason? Okay. Yeah. Yeah. I'll check that after the session. Okay. I'll go through that after the session once. So, actually, I have my textbooks and I have gone through the syllabus, but not in depth, I think. So, I'll go check it once. Okay. Fine. So, dimension analysis and all, they'll be helpful always, right? So, I think that is there. And dimension analysis will help us to prove the things to find the right answer, right? So yeah, so these are the percentage errors given, q value is given. So yeah, so what will be the percentage error in the q? It will be 4 into percentage error of a, 3 into percentage error of b, by 2 into percentage error of c. 2 ones are 2 twos are 3 twos are 6, 6 into a b by c, right? If it is a division, we have also seen that, right? If it is, as I said, see here. So 4, 3, 2. If it is division, we'll take this into numerator and it will just add on, right? So percentage is nothing but mean value divided by original value. You'll apply the sum. So whatever the numbers they have given, just substituting that is the matter. And finally multiplying and adding the things, we'll get 34 percentage. Clear? Similarly, here also they are asking for the percentage error in R, V and R, right? So we already know that R is equals to V by I, right? From Ohm's law. So if I want to take percentage change in here, it will be equal to dV by V plus di by I. So how much they have given? So change is 5 by 200 and 0.2 by 20. So finally, if you multiply the things to get the percentage, what we are getting? 100. 0 cancels. 7 divided by 25. It is 3.5 percentage. Clear? So, yeah, this was about the session. And we are done with the concepts of dimension analysis, standard units, SI units, and physical quantities. And we have also seen how to find the significant figures, how to round off the numbers. Okay, those concepts are always important because we use it in other numericals also. So yeah, this was about the session. I hope the session is clear. Right. So, yes, this was about today's session. Thank you so much for watching this session. Let's meet again in the next session with a new concept of physics. So, thank you so much for watching the session. Bye bye.